So, definition of ionization energy, you guys said the energy required to remove this is my shorthand right here. Energy to remove one electron from a neutral, that is a horrible spelling, neutral atom. Okay, so we want to point out here it's removal, because we're going to see with another one that we're actually gaining. We're actually going to gain an electron during the other one from a neutral atom. Okay, so it's from a neutral atom. Now, would you guys say it increases this way and increases this way? Is that what you guys said? Is that right?
Sorry, for the what?
For the trend, you guys said it increases going from left to right, and it increases going from bottom to top?
Yes.
Yeah, okay. So, looking at the periodic table, and for ionization energy, what's the most difficult element on the periodic table to ionize? Based on that, well, if I got to go all the way to the right and all the way up, that would be this bad boy. Okay, from the start. Okay, so why is this the case? Okay, the importante information. You guys pointed to increased. This is actually the way you denote effective nuclear charge, Z, EFF. Okay, effective nuclear charge. Z is very commonly the representative for nuclear charge. So this is effective nuclear charge. You're increasing the effective nuclear charge because of an increase in the number of protons and electrons. Okay, so you're getting more attractive force between the nucleus and those valence electrons. You're getting more attractive force. Because there's more attractive force, they're being held more tightly. And like anything that is being held more tightly, it takes more energy to remove that thing. Okay, it's harder to remove these things because they're being held more tightly. So increase effective nuclear charge makes valence electrons harder to remove. And I hope you guys realize that being harder to remove is the same thing as saying it takes more energy. That's what I'm hoping you guys got so far. And then as you go up a group, ionization energy is also going to increase because we are decreasing, my handwriting is on point today, decreasing the number of electrons and shells, therefore decreasing the amount of shielding going on in that atom. And if we're decreasing the shielding, we're increasing the effective nuclear charge. Remember, electron-electron shielding mitigates or makes smaller the amount of attractive force that an outer electron or a valence electron feels from the nucleus. And so if we decrease that amount of shielding by having, fewer energy levels, having fewer electrons in general, if we make that less, if we make the shielding less, we're going to feel more attractive force from the nucleus. And now you should see where I'm going to go with this. If we feel more attractive force to the nucleus, that means we're being held more tightly. It means it's going to be harder for us to remove that electron. And so if we are going to remove that electron, it's going to take more energy. So ionization energy is increasing. All right, ionization energy completo.